the rate law is given by R is equal to this term. What is the overall order of the reaction? In this problem, they have to given the rate equation. First, write down your rate equation. After write down your rate equation, or to calculate the order of this reaction, just add the stoichiometric power of this concentration term. The stoichiometric powers alli bardiruವಂತ termಗಳನ್ನ add ಮಾಡಿ, so you can get an order. Order is equal to power will be minus 3 by 2 plus 2 plus 0. So just you add those terms, take down the LCM. 2 is the LCM. Minus 3 plus 4, which is equal to 1 by 2. Order of this reaction is 1 by 2. It's meaning that the given equation is fractional order. The given equation is fractional order. Similarly, this type of problem will be asked for in your exam for 2 marks. This is the way to find out the order of the reaction. Come to this problem. Identify the reaction order from each of the following rate constant. So in this problem, just identify the reaction order. Which type of an order of the reaction? ಯಾವ type ಇದೆ ಅಂತ just you should mention the based on the SI unit. Here you should find out the based on the SI unit. What is the order of the reaction? We already knew that the K is equal to 3.5 into 10 to the power of minus 5 liter per mole per second. Liter per mole per second is the SI unit used for a second order reaction. For the one, your answer should be second order. For this equation, your answer should be second order reaction. For second one, 5 into 10 to the power of minus 4 per second. Here they give the SI unit as per second. It means that it is a first order reaction. Based on the given data, so you should identify the order of the reaction. Your SI unit for this used for your second order reaction. Based on per second is used for your first order reaction. Similarly, the given has the number 1 into 10 to the power of minus 3 mole per liter per second. K is equal to 1 into 10 to the power of minus 3 mole per liter per second should be given. Your order should be 0. Order should be 0. Discuss about the molecularity of the reaction. Molecularity means the number of molecule or number of reacting species which take part in the chemical reaction. Whatever chemical reaction takes place the number of reacting species will take part in the chemical reaction. Based on the in chemical kinetics, based on the mechanistically, you are classified into two types of a reaction. First one is elementary reaction. First one is elementary reaction. So mechanistical way, first one is elementary reaction and second one is complex reaction. Complex reaction. Elementary reaction means the reaction should take place in one step. The reaction should take place in one step, whereas in complex reaction, reaction should be takes place more than one step. Or involving the order of this reaction is not 2, it is 1. It's meaning that this reaction is not an elementary reaction. It do not take place in one step. It takes place in the several steps. So let us see. In the above equation, first your N2O5 gives rise to NO3 plus NO2. This is the first step. In second step, N2O5 combined with your NO3 gives rise to 3NO2 plus O2. This reaction seems to be takes place in one step, but in actually in experimental way it takes place in two steps. That's why this reaction is not an elementary reaction. This reaction should be a complex reaction. In this case, if the reaction takes place more than one step, the slowest step, the reaction which can take place in very slowly, the slowest step of the reaction indicating the order of the reaction. The rate determining step is the order of the reaction. We will determine the order of the reaction. Slowest step is the rate determining step. Slowest step is the rate determining step in case of finding the order of the reaction. It clear that our order is not a theoretical quantity, it is purely experimental quantity, and in the complex reaction our rate only depend upon the slowest step, not depend upon the reaction which takes place very fast. I will give an example for example, 4 people which can participate in the relay. So relay participate ಮಾಡಿದಾಗ the rate will be not depend upon all the 4. Speed of rate means speed. The winning rate of those 4 people will be depend upon all the 4 members, but our rate will depend upon the member which ran very slowly during the winning rate. So ಯಾರು ಅದರ 4 ಜನರಲ್ಲಿ ಸ್ಲೋ ಆಗಿ ಕೊಡ್ತಾನೋ ಆ ವಿನ್ನಿಂಗ್ ಸ್ಪೀಡ್ ಅನ್ನೋದು ಆ ಸ್ಲೋ ಆಗಿ ಕೊಡೋ ಮೆಂಬರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಸೇಮ್ ವೇ ಅವರ್ ಆರ್ಡರ್ rate will depend only on the slowest step of the reaction during the complex reaction, not on the fast step. So therefore our slowest step will be known as rate determining step. Of the reaction based on the number of reacting species involving those reactions, it may be classified into different types. Look at this equation 1. In this equation, the molecularity of this reaction is 1. It's meaning that order of this reaction is also 1. The molecularity of this reaction is 1 because the reactant molecularity is 1. Therefore, this reaction will be called as an unimolecular reaction. Uni means single. So, uni means one anta. So, unimolecular reaction. Reacting species should involve in one type at all. So, now come to this equation. 2HI gives rise to H2 plus I2. In this case, molecularity of the reaction is 2. Therefore, this is bimolecular reaction. Bimolecular as well as di. Di means bi, both will be same. It means 2. Come to this equation. 2NO plus O2 gives rise to 2NO. Here, the molecularity of the reaction is 3. Therefore, it is called as a trimolecular reaction. Trimolecular reaction. From it is clear that our molecularity is only depend upon the elementary reaction. Elementary reaction means the reaction which should take place in one step at all. The elementary reactions. So molecularity is purely theoretical quantity. Theoretically, what is the number appearing should be same as experimental way. The molecularity of this reaction is 1, unimolecular, bimolecular and trimolecular. Now I define your molecularity. Molecularity means number of reactions may be compound or compound, it may be an ion, it may be an atom, it involving in the elementary reaction. So by simultaneously combining with each other, the one molecule combined with the another molecule is called as molecularity of the reaction. It means number of reacting species involving in the elementary reaction, they simultaneously combine to carry out those reactions, is known as molecularity of the reaction. Come to this reaction. PClO3 plus 6FeSO4 plus 3H2SO4 gives rise to KCl plus 3Fe2SO4 thrice plus 3H2O. In this reaction, your molecularity of this reaction seems to be how much? 1 plus 6 plus 3, it is 10. Order seems to be 10. Molecularity of this reaction is 10. Molecularity of this reaction seems to be 10. But order of this reaction seems to be 10. But your order is not 10. Your order is 2. It meaning that during this reaction involving the several steps, if the order greater than 3 or molecularity greater than 3, that reaction cannot be determined by the rate of the reaction. It predictable will be very difficult at all. It's meaning that the reaction takes place in several steps. This is not an elementary reaction. This is purely an complex reaction. In this reaction involving the number of steps, in those steps, the step which takes place in very slowly, that step will be an rate determining. Based on this topic, we can bifurcate the what is order, what is molecularity of the reaction. There is a difference between order and molecularity. Order means it is the sum of the powers of the experimentally determined rate of the reaction. For example, this equation, order means 1 plus 0 is equal to 0. Order means it is the sum of the powers of the concentration terms of the reactant in experimentally determined rate equation. Molecularity means the number of reacting species involving in the elementary reaction. Total number of reacting species. This is the first difference. The first difference itself is the definition at all. So order means just adding the powers of the concentration term. Molecularity means total number of reacting species involving in the reaction. Now, the second difference, your order becomes an 0, order becomes an whole number, order becomes an fraction at all. But molecularity never be fraction. Your molecularity never be a fraction. Your order should be an both theoretical quantity as well as experimental quantity, but molecularity is the theoretical quantity. This is the third difference. Fourth difference, in the complex reaction, order will be depend upon the reaction which can take place in very slowly, whereas molecularity depend upon the overall reaction order. This is the difference between order and molecularity. In the next class, we discuss about the integrated